There are two kinds of type conversions. They are either narrowing or widening. A narrowing conversion converts a value to a type that cannot store even approximations of all of the values of the original type. It changes a value to a data type that may not be able to hold some of the possible values. For example, converting a double to a float in Java is a narrowing conversion because the range of double is much larger than that of float. This is an example of a narrowing conversion. A double can have up to 15 decimal digits. As you can see here in this example, we are now going to do narrowing conversion on our double value into a float. When we try to run our program, we can see that our double value that has originally 15 decimal digits has turned into a float value with only having 7 decimal digits. A widening conversion converts a value to a type that can include at least approximations of all of the values of the original type. It changes a value to a data type that can allow for any possible value of the original data. For example, converting an int to a float in Java is a widening conversion because float can hold exponents which can represent a larger range than int. This is an example of a widening conversion. The value of int p here is the largest possible value that int can hold. If we are going to convert our int value to a float, the float should be able to handle all of the possible value of the original data. The integer value has been converted into a float value. The float value, as we can see here, is represented with an exponent, which float values have. Widening conversions are nearly always safe, meaning that the magnitude of the converted value is maintained. Narrowing conversions are not always safe. Sometimes the magnitude of the converted value is changed in the process. For example, if the floating point value 1.3 E25 is converted to an integer in a Java program, the result will be only distantly related to the original value. However, even though widening conversions are usually safe, they can result in reduced accuracy. In many language implementations, although integer to floating point conversions are widening conversions, some precision may be lost. For example, in many cases, integers are stored in 32 bits, which allows at least 9 decimal digits of precision, but floating point values are also stored in 32 bits, with only about 7 decimal digits of precision because of the space used for the exponent. So integer to floating point widening can result in the loss of 2 digits of precision. This is what happened earlier when we converted our integer value into a float value. Type conversions can be either explicit or implicit. One of the design decisions concerning arithmetic expressions is whether an operator can have operands of different types. The languages that allow such expressions, which are called mixed mode expressions, must define conventions for implicit operand type conversions because computers do not have binary operations that take operands of different types. When the two operands of an operator are not of the same type, as shown in the demonstration, and that is legal in the language, the compiler must choose one of them to be coerced and supply the code for that coercion. Coercion is basically an implicit type conversion that is initiated by the compiler. Assume that the second operand of the multiplication operator was supposed to be C, but because of a keying error, it was typed as A. Because mixed mode expressions are legal in Java, the compiler would not detect this as an error. It would simply insert code to coerce the value of the int operand A to float. If mixed mode expressions were not legal in Java, This keying error would have been detected by the compiler as a type error. Programming languages like Ada, ML, and F Sharp do not coerce operands in expressions. Any necessary conversions must be explicit. We will try to use our example earlier into a Java program and see if there will be a keying error. The compiler did not see or detect any keying error. The C-based languages have integer types that are smaller than the int type. In Java, they are byte and short. Operands of all of these types are coerced to int whenever virtually any operator is applied to them. So while data can be stored in variables of these types, it cannot be manipulated before conversion to a larger type. For example, consider the following Java code. The values of B and C are coerced to int, and an int addition is performed. Then the sum is converted to byte and put in A. Most languages provide some capability for doing explicit conversions, both widening and narrowing. In some cases, warning messages are produced when an explicit narrowing conversion results in a significant change to the value of the object being converted. In the C-based languages, explicit type conversions are called casts. To specify a cast, a desired type is placed in parentheses just before the expression to be converted, as in one of the reasons for the parentheses around the type name in these such conversions is that the first of these languages, C, has several two-word type names, such as longint. In ML and F Sharp, the casts have the syntax of function calls. For example, in F Sharp, we could have the following. Several errors can occur during expression evaluation. If the language requires type checking, either static or dynamic, then operand type errors cannot occur. The other kinds of errors are due to the limitations of computer arithmetic and the inherent limitations of arithmetic. The most common error occurs when the result of an operation cannot be represented in the memory cell where it must be stored. This is called overflow or underflow, depending on whether the result was too large or too small. One limitation of arithmetic is that division by zero is disallowed. Of course, the fact that it is not mathematically allowed does not prevent a program from attempting to do it. Floating point overflow, underflow, and division by zero are examples of runtime errors, which are sometimes called exceptions.